All right.
All right.
All right. Our last speaker today before our short break in the next session then is Lou Martinage from TRX Systems, speaking to improving first responder safety and situational awareness. Lou?
Thank you, Chris, and good afternoon, everyone. I am Lou Martinage, Director of Product Management here at TRX Systems. Not to be confused with the exercise band company. Our core expertise is really in the area of sophisticated location tracking solutions, tracking people and things in situations where GPS is unavailable, like inside a building. And that same technology that can be used to georeference people, we can also apply to other things, to georeference, for instance, radio and cellular signals for public safety. And that's a concept we call signal mapping. And it's kind of what our phase 1 and phase 2 SBIR programs with DHS have been all about, sort of exploring ways to take our existing signal mapping capability and extend it and harden it to help address communications challenges in the public safety community. So, I think everyone can probably agree that reliable radio communications is vital for first responders, right? It's essential for their situational awareness and their safety while at an incident. And our core hypothesis in this phase 2 SBIR is that there is tremendous untapped value benefit in putting LMR and FirstNet coverage information directly into the hands of the first responder community. And here on this slide, it's sort of two ends of that community. The obvious one being the firefighters themselves. At an incident, wouldn't it be great to give those firefighters in real time, before they walk into the building, some insight into whether their radios will work inside? If they know that, then they can adjust their protocols accordingly, maintain safety, make sure everyone's okay. On the flip side, on the command team, where the authorities are, it would certainly be useful to have a broader view of what's happening within their domain, their area of responsibility. There could be hundreds of buildings within, say, the 2 or 3 square mile area around an urban firehouse. And it certainly would be useful to know where the gaps are so that community can respond accordingly, invest some money where it's needed, or put requirements to improve that coverage through distributed antenna systems or installing bidirectional amplifiers or what have you. So that is all great in concept, but unfortunately today there's really no centralized mechanisms for doing that, for collecting and sharing that coverage data among a large community of users and keeping it updated. It's certainly straightforward today for an RF engineering company to go into a single building and analyze the radio coverage, either on behalf of the cellular operators or maybe for public safety as well, and put a report together. And the tools are readily available. There are spectrum analyzers and software-defined radios for doing that kind of work. But generally, it's a one-off exercise. Someone needs an occupancy permit, sign off from the fire marshal, kind of a check the box and done. And once that information's collected, it doesn't really see the light of day again. And it would be nice to put that information to work for the public safety community. And that might mean, as depicted here, putting a mobile app of some sort, either on a tablet or a phone, in front of the first responder or the captain of the squad, indicating what that building coverage looks like before they walk in. Or on the other side, large scale metropolitan area wide dashboards that indicate what buildings are covered, which ones are uncovered, and where I might have some coverage gaps. So what's needed? So what would we need to do? This is really what this ICAS idea is all about, is building an ecosystem, an organized ecosystem for putting this radio coverage information to work. And the first element is collecting that information and in a different way. We have to find a way to collect that coverage information at scale. And then we need to find places to store it in sort of an evergreen kind of way where we can refer to it often, update it when possible, and then make it available through other sharing mechanisms. So that would be multiple form factors depending on who needs to look at it. So my firefighter might need a different view than my commander at headquarters, and so forth. And that ecosystem is really what we're talking about with our work with DHS. So let's talk about what we've been doing. Our first realization is that conventional approaches just aren't well suited to this task. The RF testing equipment that's out there, spectrum analyzers, is expensive. It typically takes highly trained people to use. Walking a building and doing the actual coverage mapping can be a cumbersome and manual process depending on how you're doing it. And as I mentioned, it tends to be somewhat fragmented. A building gets done, a report gets filed, and maybe it doesn't get seen again until a year or two later when a subsequent check needs to occur. So what we're doing in this phase 2 SBIR is building a new ecosystem. And a lot of moving parts on this slide. I'll try to take them in turn here. But what we're starting with is TRX's core technology, which I mentioned is called SignalMapper. In the middle of this screen, you'll see an Android phone. So SignalMapper is part a location engine that's running on the Android phone. And it takes inputs, inertial inputs from that little tracking unit shown down below. So a person walking along inside a building is generating sensor data that is collected by the mobile app, and it combines that with other information it might know, like GPS or other building information, to compute that person's 3D or XYZ position in a building. Now, while we're at it, we can also then take other information that might be near that person and also geolocate it. So that could be wireless signals from the phone, like Wi-Fi or Bluetooth, or cellular services, or from things connected to the phone. So another piece of the puzzle here with our SBIR is working with public safety radio vendors to extract signal information directly from their radios, either over Bluetooth or a direct USB connection, so that we can take those RSSI or bit error rate signals, georeference them, and then create a heat map indicating the coverage on any floor on any building, and then also indicate whether that pass failed. We can create coverage grids. You'll see here that indicate, you can see visually very quickly whether that signal passed or failed the desired thresholds, and then we store all that in the database where it can be made available for other entities, a centralized entity who wants to see all the buildings in an area, or again, that firefighter about to walk into a building. And the whole idea is to make it simple and automated so that lightly trained personnel can make it happen. So at this point, I will attempt my video demo just to give you a little flavor for what this looks like. What you're looking at here is a coverage map for a building, two-dimensional. You'll see some grids here. This building has already been mapped. Each one of these boxes has two signals in it, a signal off a Motorola phone, an LMR signal, as well as a FirstNet signal from a Motorola radio, and FirstNet from a Samsung phone. And the colors indicate pass fail thresholds. The light blue is pass, the dark blue is fail. More typically, it would be red or green. So I'm just going to start this off here and walk you through what's happening. And hopefully you can see it all right. I'll stop it periodically. I have two signal mappers walking through this facility, someone named Roland and Vanessa. And you'll see as they're rolling through, the breadcrumbs indicating the signal levels they're picking off as they walk through the building. And as they walk through some of these different grids, you'll see the signal levels change. Here's a 3D view. I mentioned we do this in 3 dimensions. On the left side of the screen, you'll see the mapper's screen. This is actually Roland's screen on his Android phone as he's going through the building. And you'll see here in a moment, he's going to go down a stairwell, and you'll watch these signals get tracked all the way down the stairwell, all happening in real time. And he'll be down here on the bottom floor in a second. That 3-dimensional capability is very important for first responders who want to see good coverage in stairwells and elevators. So this is a great vehicle for doing that. And I will also add both of these. This is all happening simultaneously. So we're collecting all these inputs from multiple signal mappers at the same time and creating this unified view, and which then could be immediately spit out to reports in real time, which is super cool. So let me keep plowing ahead here. So here's specifically what we're building out for the program. There's a mobile app toolkit, which I mentioned. This is the Android app working with our SignalMapper, connecting into third-party public safety radios and georeferencing the LTE and LMR signals. That is all being stored in a cloud database, and it's a pretty big job. We're trying to, again, do this at scale, which means lots of reports, lots of inputs and people, and the ability to come back and refresh that information at any time so that we can have timestamps and compare back and forth from one measurement to another. And then I mentioned the large dashboard, really having a hierarchical view from every floor of every building and every campus within an overall metropolitan area or area of responsibility, the ability to view pass-fail status of signals, indoor and outdoor, two-dimensional and three-dimensional, and put them in the hands of interested parties. Grayed out here at the bottom is something called a mobile viewer app that we're still working on that would give first responders a cheap, easy tool to download from Google Play and look at coverage. So key features and benefits. The first thing is this is all about what we talked about at the beginning, making coverage data available to a broad set of constituents, multiple form factors, so that we can give different views of the coverage situation to different people. We've tried to make it easy to use with highly automated capabilities, use existing devices, and do everything simultaneously. So it's one walkthrough with devices, all automated, and then flexibility to meet the needs of different groups, be able to go in there and set different thresholds, set different colors and grids, do indoor and outdoor analysis so that we can meet the needs of different people. From a commercialization perspective, we're not just targeting public safety. We think right out of the gates, RF engineering companies will be interested in this project. It would work with things other than just public safety radio and LTE, so it could meet their needs today in a more automated fashion than what they're doing already. Folks who are big manufacturing organizations or utilities who might have their own radios could take instant advantage of this to check the integrity of their system. And then finally, public safety, as we mentioned, putting real-time awareness into the hands of first responders. That's where we're heading with this. So here's where we are, and I know I don't have much time left. We've spent a bunch of time. We're in year one. First half here has been all about hardening the capability. By second quarter this year, we want to deliver some beta testing kits for feedback, which is what this is all about. And then we've got some feature development to add some additional capabilities for the viewer, some more subscription flexibility, and then have this thing out the door by fourth quarter. Little commercial about us. TRX has been around about 10 years, cut our teeth in the world of personnel tracking at large events, situational awareness right here in the middle. We did some Super Bowls and All-Star games. That morphed into tracking things that are with people, such as signals, photos, notes. That's the coverage validation, signal mapping on the left side. And more recently, we've been doing a lot of work with the military, tracking personnel in challenging GPS-denied environments. So after that whirlwind, my whole mission today is to put this out there and solicit some feedback. We have a hypothesis about what is good here, and believe that putting LMR and FirstNet coverage gap information into the hands of first responders is useful. And so I'd be curious if anyone wants to share. If you had such a capability, how would you use it? Are there additional capabilities that would be useful? I also mentioned we're going to be doing some limited beta testing in the coming months. And if you have an organization that you think might be willing to check this out, you can contact me directly. So I guess at this point, Chris, I would open it up to any questions.
All right. Thank you very much, Lou. Perhaps you can move it to your contact slide.
There we go.
Perfect. All right. We do have a first question in for you, Lou. Does your solution work with other wireless technologies besides LMR and FirstNet LTE?
So I touched on this, I think, a little bit, but so the ICAS solution we're doing specifically for DHS and the SBIR is focused on LMR and LTE. However, the product itself, the capability itself, can really do georeferencing of any set of signals. So it could be Wi-Fi and Bluetooth right off the phone, any cellular service. It can take sensor data from radiation sensors or other devices. So it's actually very versatile in terms of taking any third party information and georeferencing it in 3 dimensions.
All right, great. Our next question then is, would the SignalMapper application have the ability to report to an on-premise server outside the cloud for those of us with sensitive site information, for example, Department of Defense, Department of Energy?
Yes, that would be possible. We do have flavors of our solution. So we have other customers who are sensitive about keeping their information in a, I don't call it public cloud. So we do have an architectural capability, and we actually allow someone to have a separate server, a private server on which to store their data.
All right, fantastic. Next question then for you, Lou, is, are there outdoor use cases for this technology?
Yes. So, again, the general focus when we've been talking about this is indoor. Typically you lose GPS when you go into a large building, which is where the firefighters are operating. But from a public safety perspective, we've had increasing requests from people who do this mapping for a living to have coverage information in the outdoor areas, specifically around buildings. So you might imagine a campus, like a school or college with 5 buildings. The first responders want to know if they can talk on their radios outside as well as inside. So in the product, we have built in that capability to go walk those outdoor spaces and incorporate them within the same reporting in a very seamless fashion.
All right, fantastic. Next question then for you. Can this also be used as a personal location system that can integrate into a CAD AVL system via LMR radio or cell, LTE?
Could you repeat that just one?
Sure.
That first one?
Yes. Can this also be used as a personal location system that can integrate into a CAD/AVL system via LMR radio or cell?
So the roots of this technology are actually in personnel tracking, which I think is where the question is going. So today we use these inertial technology to track people indoors, and their XYZ coordinates. We have something called the Neon Command, which is our command center, which is where one would view those personnel as they move through a building, say a group of firefighters. We could also put that XYZ position into another situational awareness tool as well. So I think the answer is yes.
All right, great, thank you. See, if anyone else have any questions, please post them in the Q&A box or email it to the email address as Dusty has posted previously. Or if you want to, you can reach out to Lou directly at his contact information here on the slide. All right, just double check. Does not look like we have any more questions coming in. All right, Lou, thank you very much. Have a great day.
All right, Chris, everyone have a great day. Thanks very much for the opportunity.